It made me very sad listening to Dijkstra. But that was a beautifully, beautifully constructed talk. Those two problems. I think it's only two, or is it three? I didn't get to the end of problem two. I sent Jade an email. She asked for people to fact check a script she had for a video about Principia Mathematica. But I was thinking about what I was talking about, smooth functions, and how observers in physics construct space by talking about the relations between objects within it. And that's what a natural transformation, that's kind of what is captured by the idea of natural transformation. And it's inherent in all the proofs in Euclid's Elements. You only have to look at proposition 1 and proposition 2, which are both problematic in the sense of Euclid, which means that they're to do with construction. In proposition 1 in book 1, the construction is a perpendicular to a given line. And in proposition 2, the construction is a line of an equal length to a given line at a point, and these two constructions, the construction in proposition 2 makes use of the construction in proposition 1. So it's a composition of constructions. And a lot of the modern early 20th century criticism of Euclid seemed to be around the insistence that certain points, such as the intersection of two circles, the existence of these points, and that was kind of the background that Russell and the early attempts to make calculus rigorous and in Russell's on denoting, he gives the example of the center of gravity of the solar system as being a point with which we can only make the acquaintance of by denoting terms or denoting phrases. And if you listen to problem 1 that Dijkstra talks about, which is this problem of the urn, there's a kind of edge case. He actually says the urn is not empty. He doesn't say the urn contains at least 2 balls. And you can trivialize it by saying, well, if the urn contains only 1 ball, then just add a white one without loss of generality and then take 2 out. So you can, even if the urn only contains 1 ball, you can know the contents of the urn at the end. But my observation that the parity of the number of white balls is a hidden variable. there's something non-well-founded about it. Because you start not even knowing how many balls are in the urn. And it's a bit like observers around the solar system who are calculating their positions in each with their own ephemerides. They don't have that datum, which is the center of gravity of the solar system. They aren't acquainted, and they will never be acquainted to it directly. These observers, imagine them zooming around in spaceships. They're constructing a coordinate system. They don't know exactly where the origin is. It's a hidden variable in the same sense. It's a placeholder for a datum which you're never necessarily going to have. But those observers can still communicate and talk sense about their relative positions and their knowledge of their relative positions, assuming they can communicate. And it turns out that Louvière's 1967 or 1969 paper on fixed points actually mentions 1 + 1 is 2. But that's also about topology and holomorphic functions, and it's really interesting. There is an intuitive basis to this extremely abstract mathematics. And that was kind of what I was exploring when I was writing that bizarre chapter I wrote about Gödel and Einstein and what a weird thing the exponential function is. But maybe for people reading what I wrote, it sounds extremely abstract. But to me, it didn't seem abstract. I thought I was giving thought I was kind of doing it ground up rather than top down. But I wrote a bit about there's something dynamic about the process of proving, which isn't captured by Hilbert-style proof systems. And the dynamism, to try and explain what it is, it's the if you can take the Hindley-Milner type inference algorithm and write a program which describes some sort of process. So it's a function. And that program has a type which you can deduce from the Hindley-Milner algorithm. And it has these type variables which are undecided. And you can compose those programs and furthermore deduce the types of the compositions. I modified that Hindley-Milner algorithm to actually produce proofs, formal proofs, using, I can't remember the name of those little tableaus with, but I just printed them off. And that's what I'm getting at with that, by the dynamic element to proving theorems, that it's a process. So you can imagine these observers in the solar system sharing their information in the form of programs or proofs that programs that produce proofs which depend upon data with which none of them are directly acquainted. And it all depends on the fixed point of the chain rule. I don't know enough technology. I need to learn all these terms like right adjoint and but adjoints aren't that high up the category theory tower. I should be able to look that up. You just have to watch out for realizations of theories which aren't which have aspects that aren't captured by the theory that you're realizing. It's the problem with churches, maybe. Yeah, I think that might be the problem with churches.